So last week we looked at section 2.2, which was on unit circle trig. And the kind of question you would have seen last week, like from the test, would have been something like this. So, I would have given you a trig function, okay, given you an angle, and then I would have asked you for the question mark. Okay, what is the sine of 45 degrees? Well, this week, we're going to reverse it. Okay? Instead of me giving you an angle, you're going to see a question more like this. So I'll give you, okay, what would be on this side? I'm going to give you that answer. And you're going to have to work backwards and tell me the angle. So it's pretty much exactly the opposite kind of question you would have had from last week. So what this is called when we do it the other way, it's called inverse trig. A regular trig is what I showed you last week. This is going to be the reverse. So what an inverse trig function is used for is basically to undo or kind of go back in reverse what we did last week. I'll show you an example on the calculator. And I'll show you, if you don't know how to type in what I'm about to do, that's fine. I'm going to show you how to do it throughout the week. All right, so for angles that weren't multiples of 30 and 45, we've been using the calculator to figure out the answer. So let's put it in degrees. And pick one that we couldn't do on the unit circle, like 23 degrees. So we take the sine of 23, and you get that, 0.3097. Now, I'm going to take 0.3097, and instead of doing the sine of it, I'm going to do what's called inverse sine. What do you think I'm going to get when I hit enter? I'm going to get 23. I rounded it so it's not exact. I'll probably get like something very close to 23. Let's see.
You put in the wrong number.
I put in the wrong number. We should get 23. Just switched them. 0.3907. And we get 22.998. Okay, very, very close to 23. The point is it undoes what you did. It gives you back what you started with. So if you look, okay, what I typed in, it says sine, but it also had this little -1 next to it. Okay, kind of like where an exponent would be. That -1, it's not an exponent. I know it looks like it's a little bit higher, but that -1 is just a symbol that means inverse sine. Usually when you do inverse sine, you're not going to see it written out, like the word inverse sine. You can see it written one of two ways. That's the symbol that I'm going to use. Okay, and it's also the symbol you'll see on a calculator. And the other way you can write inverse sine is arc sine. That's also an abbreviation for inverse sine. All right, so if you saw a problem that said something like inverse sine of 0.2, it said to figure it out, or it said arc sine 0.2, same question, just a different abbreviation. Again, that's the one that I'm going to probably use most often. Okay, same thing for inverse cosine. Okay, the symbol for that is cosine with a -1 on the calculator, or you can write arc cosine. And inverse tangent, same idea again. Tangent with a -1 or arc tangent. Okay, so again, just to be clear about that, this -1 is not an exponent. Yes, it's written a little bit higher. Now, normally when you write a number a little higher, it is an exponent. But when you put a -1 there, it just means inverse cosine. And what makes it even more confusing is if you put a number there other than a -1, it is an exponent. So -1 is kind of a special symbol. It's not an exponent, but any other number would be. You're not going to have to worry about other numbers there. Okay. Any question on the abbreviation? Okay. So, if you start doing a bunch of inverse trig problems, like let's just type in some. Let's do inverse sine of 0.3. Okay. Inverse sine of 0.9. Inverse sine of -0.78. Okay. You can see the kind of answers we're getting. 22, 17, 64, -51. Well, there's a pattern to them. You're always going to get an answer that's between -90 and 90 when you do inverse sine. If you're doing it in radians, okay, you'd get an answer between -pi/2 and pi/2. Okay, remember, any of these problems we're doing in degrees, we can do them in radians as well. When you do inverse cosine, you're always going to look for an answer between 0 and 180. You always get an answer between 0 and 180, or if you're doing it in radians, that's 0 to pi. And inverse tangent, it looks similar to inverse sine, but that is a little different. It's -90 to 90, but does anybody see what's different about it? Yep.
Instead of like a less than or equal sign, it's just the less than.
Yeah. You can't actually get an answer that's -90 or +90. And when I show you guys a chart in a minute, you'll see what happens if you go to the tangent column in this chart and you try to go down to 90. I'll show you real quick. You go to your tangent column, when you go to 90, it says, I don't know if you can read it or not, but it says undefined right there. Okay, so when you get to 90 in tangent, you can't do that. Now, there's 3 trig functions that I left out. I didn't really talk about inverse secant, inverse cosecant, or inverse cotangent. We'll mention them quickly, probably, I don't know, maybe later today or tomorrow, but those 3 are not something we're going to spend a lot of time on. The main reason is you don't have a button for it on the calculator, so it's more annoying to have to work with those 3, and really, you can do everything you need to do with these 3. You don't really need the other ones. But we might talk about them real quick. We'll see. All right, so let's take a look at something. So I gave you guys a bunch of ranges, right? I told you inverse sine, you're always going to get an answer between -90 and 90. Inverse cosine, I said 0 to 180. Well, there's a certain reason that we picked those numbers. You don't have to pick those numbers, but those numbers I gave you are the most common ones people usually do pick. Right, so let's look at this table. What I want to do is just fill in some of these values. So I've got an angle in the left, and then in the right column, I'm going to put down the answer when I take the sign of it. Right, so let's do 30. So if I press sine 30 and I hit enter, I get 0.5. So if I take the sine of 30, I get 0.5. What should I get if I take the inverse sine of 0.5? 30. It should bring me back to what I started with, and it will. You can check it. All right, let's do 65. All right, this one doesn't come out as nice, but the sine of 65 is about 0.91. So Dylan, if I took the inverse sine of 0.91, what angle should I get roughly back?
65.
I should get, yeah, I'll probably get about 64.9 or something because I rounded it. But yeah, I should get about 65. All right, let's take the sine of 90. So So sine of 90, and we get 1. So if I take the inverse sine of 1, it'll bring me back to 90. Now, let's do 150. Sine of 150. 0.5. We've already answered this question, but I'm going to ask the same question again. If you take the inverse sine of 0.5, what are you going to get? 30. We said earlier we were going to get 30. Well, we can't all of a sudden get a different answer now. So the problem here is you have two angles that when you take the sine of them, the answer came out the same. That's not good. Because that means when you're trying to go back from inverse sine of 0.5, well, which answer would you say? Is it 150 or is it the 30? Well, let's see what the calculator does. Inverse sine of 0.5. It gives me the 30. It doesn't give me the 150. It's not that the 150 is wrong. 150 is right if you do inverse sine. The problem is when you do inverse sine, you only want to give one answer. And we want to have a way to agree on what answer are we going to give. If we always agree to give the answer that's between negative 90 and 90, there will never be more than one answer. Yep. So the two choices we had when we did that was 150 and 30. Well, 150 is not between these two numbers. That's why the calculator didn't say 150, and it said 30. All right, so that's kind of why we use these numbers. If we don't, then there's an infinite number of answers to every single inverse question I ask you. Right? And we don't want an infinite number of answers. We want to have just one answer, and we all want to agree on what that answer is going to be. So always follow these three rules. When you have a choice of more than one answer, pick the one between negative 90 and 90 when you're doing inverse sine. Pick the one between 0 and 180 for inverse cosine. And pick the one between negative 90 and 90 for inverse tan. Any question on that idea? All right. All right, so this is just kind of summarizing again what I already told you. So what we're doing this week is basically the opposite of last week. This is the kind of problem you would have seen on the test last week. Okay, I would have given you a trig function, given you an angle, and then said to you, what's the sine of 30 degrees? And if it's a multiple of 30, we learned how to find the coordinate and do unit circle. If it wasn't, then we use the calculator to figure it out. All right, but the main kind of point here is, I gave you an angle, and you found the trig function of that angle and told me the question mark. This week, the problem looks more like this. Instead of me giving you an angle, the angle is going to be the question mark. So this is saying, what angle could you take the sine of, and you'd get an answer of 1/2? And the answer is 30. If you take the sine of 30 degrees, you will get 0.5. We just did that in the table. So how would you know how to do that? Right? How would you figure out what x is? Well, if the answer is a multiple of 30 or 60, we're going to have a chart we can look it up on. And I'll show you how you use this chart. This is the chart I was talking about that you can print out and you can use in addition to a reference sheet this week. All right, so what I'll do is let me put the whole chart on the screen. So at least if you go to the video at some point, you could screenshot that and print it. But I also think I uploaded the chart as a PDF. But if not, there it is. All right. So the first thing we want to figure out is, how do you know when to use that chart? Because I can't put every single answer that ever exists in this chart. You'll notice that all the angles here are multiples of 30 or 45. So how do you know if your answer is going to be a multiple of 30 or 45? Well, look at all the numbers in this chart. If you're given a number like square root of 2 over 2, square root of 3 over 2, 1/2, 1, 0, -1, -1/2, any number that you see in this chart, which take all of the numbers that we talked about last week when we did unit circle trig, you're going to be able to find the answer in this table. All right. So again, you're gonna look for things like 1/2, 1, √3/2, √2/2, √3. That's what you're gonna look for. And when I say look for it, I mean, I'll come right back to that. I mean, look right here. Look at the number that's inside the parentheses. That's called your argument. Okay? That's a 1. If the argument is a 1, you're going to find it in that chart. -1, you're going to find that in the chart. Zeros, yep, those are in the chart. -1/2, those are in the chart. Square root of 3s, those are in the chart. 0.65, no. 0.65 is not a number that's in the chart. If you look at it, you don't see any 0.65s in any of these columns. All right, so you just kind of get used to what numbers appear in these columns and check, is that a number that appears in the columns? If it is, you use the chart. If it's not, then you have to use a calculator. All right, so let's take a look at a few examples and see how we use that chart. Okay?
Can I go to the bathroom real quick?
All right, so first problem says inverse sine of 1. So if you're kind of confused, like with this -1 thing, and you're like, well, what does this really mean again? This question means this. What angle could you take the sine of and get an answer of 1? That's what this question means. It's exactly the same thing. What angle can you take the sine of and get an answer of 1? So first thing you do is, all right, sine. We're going to look at the sine column. We're going to go down the sine column until we find a 1. Once we find a 1, we're going to read off what angle is in that row, and that's the answer. All right, so let's look at our chart. So you're focusing on the sine column, and I'll have to scroll down maybe a little bit, and it continues over there. So as we go down the sine column, all right, so we're going to go down the sine column, and we're going to go down until we find a 1. If we find it more than once, and you have multiple answers to pick from, remember, you want to pick the answer that is between -90 and +90. All right, so let's look at our chart. Okay. Anybody tell me, as we go down the sine column, go till you find a 1, and then tell me what angle is in that row. Yeah?
90.
90. So I see 90. It's also written below it. Might be a little hard to see, but it says -270 because 90 and -270 are the same angle. So what I've done here is I've given you the positive and the negative version because you don't know which one you're going to need. Depends. All right, let's keep going. See if we see it again. No. And if we keep going, no. Doesn't look like we see it again. So we have two choices, 90 or -270. What's the one that we would pick here for the correct answer? Yep.
90.
Yep. Here we go with 90. That's important when you write your answer that you do put a degree symbol on it, or a radian if you're doing radians, because you are finding an angle. So that's kind of an important idea. The answer to an inverse trig question is always an angle. That's what you're trying to figure out. So anytime you have to solve for an angle in trig, which is kind of where we're going with this, we'll be given a triangle. You're going to have to figure out how big an angle is. The way you figure out how big an angle is always use inverse trig. You just have to figure out the number that goes there for your problem. right now I'm giving you that number, so you don't have to worry about where this number came from. All right, let's try this one. So inverse sine of -1. Okay, so another way to think about that question, what angle can you take the sine of, and the answer comes out to -1. So let's first bring up our table and see if -1 is something that's in there. Yeah, I see -1s all over the place, so you'll find that number. Just make sure that you are in the sine column. So Devin, if we go down the sine column, where do you see -1? I don't think I see it on the left, so let's look over on the right side.
270 degrees.
Yep, 270. And what's that the same as a negative angle?
90. -90.
-90. Yep. So we either can go with 270 or -90. And what's the one that we would want to pick? Remember what we're supposed to be between.
Would it be -90?
Yep, you got to pick the -90. Okay, it's not that the 270 is wrong, it's that we're only looking for one answer. So what's the answer we're going to agree on? It's the -90. All right, so answer here, -90. Or let's just practice doing it in radians in case they wanted that answer. The answer in radians is right next to it. I know it's hard to see, but it's -pi/2. Okay, you can just look it right up in the table. Which one of those is correct? Both of them. One's degrees and one's radians. On the test, I'll make sure that I write down, put your answer in radians or put your answer in degrees.
You answered my question. Thank you.
You're welcome. All right, let's try this one. The inverse sine, so this tells you what column to look at, of 1/2. I think we actually already did this one in the table earlier. I wrote 0.5, but it's the same thing. Anyone remember what the answer was? The inverse sine of 0.5, Caitlin?
30 degrees.
Yeah, it was 30. We just did it, so let's see if we can find it on here. So go down the sine column till you find 0.5. All right. There's two possible options, 30 and -330. And once you find the one that's between -90 and 90, you can stop. You will find 0.5 again. You keep going down. Right here. 150 and -210. Okay. So I think this is the first time that that's happened. We see the 1/2 twice in the sine column. Out of those four answers, only one of them is between -90 and 90. 150, no. -210, no. -330, no. 30, yeah. That's the only one. Any question on that one? Or, if they wanted it in radians, you could write pi/6. All right, let's try this one. Inverse sine of √2/2. So I know we're practicing with the table, but first thing you should ask yourself, is that even a number you're going to see in the table? Well, square root of 2/2, go to your table. Yeah, I see square root of 2/2's all over the place in the table. So you'll find it. So anyone think they see what angle you can take the sine of, and it will come out to √2/2. And if you see more than one, just give me the one between -90 and 90. Yep.
45.
45. So you had a choice of 45 or -315. No, you're not using the -315. You'll see √2/2 again right here. 135, no. 225, no. We found the answer right away. Okay. 45 degrees. Questions on that one? You're welcome. Let's write that down. Try one more with inverse sine. Inverse sine of negative root 3 over 2. So question, what angle can I take the sine of, and I get that as the answer? So, negative root 3 over 2. I see root 3 over 2's all over the place in this chart. So you should be able to find it. And remember, you're looking for negative root 3 over 2. If you accidentally do positive root 3 over 2, it's not going to come out right. Okay, I don't see it on the left, so let's look over on the right side. I think where I've scrolled, you can see the answer. Anyone think? See the answer yet?
240.
All right, so I agree that 240 and negative 120 are options. Anywhere else that we have a negative root 3 over 2? Yep.
Negative 60.
So we have the 300 and the negative 60. Okay, I'm looking at this right here. In this case, you want to go with the one between negative 90 and 90. So negative 60 is what we're looking for. Any questions on that? All right. So now we got to kind of switch what we're looking for a little bit. Inverse cosine. Now you're not looking for negative 90 to 90 anymore. What did I say earlier you want to be between for these two? If you look negative 90 to 90, you may come up with two answers. And that's because negative 90 to 90 is wrong. Yep?
0 to 180.
0 to 180. Okay, if you focus on 0 to 180, guarantee you, if you find more than one answer, that will eliminate all the other ones. All right. So, what does this problem really mean? What angle, solving for an angle, could you take the cosine of and get an answer of 0? Get our table. Okay, I think, yeah, answer is up there. Let's see. Yeah, go ahead, Ariana.
90 degrees.
Yep. So go to your cosine. Keep going down till you find a 0. Got some traces right here. Then you got some more traces over here. 90 degrees is the one we're looking for. Negative 270. Nope. It's not between 0 and 180. Positive 270. Nope. Negative 90. Nope. 0 to 180. So 90 would be correct. And if they wanted radians, you could put pi over 2. Alright. Let's try inverse cosine of negative 1/2. So you're looking for an angle you can take the cosine of and get negative 1/2 as the answer. And if you're not sure, we're in the 4th column. So you're looking here. That's the cosine column. And here. And I scrolled enough that you should be able to see the answer. Yeah.
120.
120. So negative 1/2. 120. Is that between 0 and 180? Yep. Negative 240? Nope. You got 2 more answers over here, but those aren't going to work. 240 and negative 120. So, any question why 120 is the answer? Okay. This table's pretty easy to use. And let's do one more with inverse cosine, and then we'll try inverse tangent. So, inverse cosine of negative root 2 over 2.
Do you mind? Or mine?
Yeah, just go down. Let me zoom out so you can see it a little better. Okay, what are we looking for? Negative root 2 over 2? Okay, I think you can, yeah, you can see all the different options. What's the inverse cosine of negative root 2 over 2? Yeah, Gina? Okay, sorry, can you say it one more time? 135, let's check. Go down the column, still put a box around it so you can see which one it is. 135, there you go. Okay. Questions on that one? So look at this chart in general. Okay, if you look at the sine and the cosine column, you're going to see numbers, okay, in all of it. When you start to look at the other four, the tangent, cotangent, secant, and cosecant, you'll see undefined sometimes. And we talked about undefined last week. Usually it happened when you had a coordinate and you were dividing by 0. Right? So there are certain values here that are undefined, and basically you should never give me an answer. You're never going to have to look for undefined. So if you see an undefined box, you can just skip right over it. You don't even have to look at it. There's nothing there that's going to help you. All right, so let's try inverse tangent square root 3. Okay, first of all, Mia, is square root of 3 a number that comes up in the chart? Let's take a look. What do you think? Do you see any square root of 3s up in the chart? Yeah, there's some square root of 3s in here. So we should be able to find an answer. Let me just clear the whole chart. Zoom back in. And what are we looking for? Root 3. All right. Now we got to kind of switch gears again. Inverse tangent. What are we supposed to be between this time?
90 or
Negative 90 and 90, but it'll never include negative 90 or 90. You don't even have to really remember it, because if you try to include 90 when you go to tangent, you can't. It says undefined. Okay. All right, so what's the inverse tangent of square root of 3? Yep.
60.
60. There's your square root of 3, and it's 60. You will see it again. Where is it? Over here. But those answers are 240 and negative 120. They're not in the range we're looking for. They're not wrong. They're just not the answer we're looking for. Okay. So 60. Right. And I'm not going to do as many with inverse tangent because we've been practicing a lot. Let's do the inverse tangent of negative root 3 over 3. So looking for negative root 3 over 3. So I see it here. Not really liking any of those answers. 150 and negative 210. So let's keep looking on the other side. Yep.
It'd be negative 30.
So very last one, I think it's the last one. Okay. Negative root 3 over 3 gives me choices of 330 and negative, that says negative 30. Negative 30 is what we're looking for. If you can't find an answer between the intervals I said, then you did something wrong. Either you got the wrong interval or you're, I don't know, but you'll always find one. Okay, so negative 30. Hey, any questions on using the on the chart?
We'll get the chart for like homework and stuff, right?
Yeah, you can just pull up the video and pause it.
Okay.
So I don't have a printed copy, but yeah, it'll be in the video. And I think I might have attached it as a PDF file too. Might be in a handouts folder.
Do we use it on the test?
Yes. Yep, if you print it, you can use it. You will have to print it if you want to use it for the test. All right. So, what if we can't find the answer in that table? Okay. Well, then we're going to use a calculator. So this one is inverse sine of 0.65. What does that really mean? What angle can you plug into the sine function and get an answer of 0.65? Now, if we go back to the table, let's see if we see 0.65. Is 0.65 a number that comes up anywhere in that table? I mean, you can check some of these, like you can divide this out, 1 divided by 2, that's 0.5, that's not 0.65. The square root of 2, that's about 1.4. So you can check them all, but you're never going to find one that's 0.65. Okay? All right. Depending on your calculator, there's a couple different ways you type it in. This calculator works exactly the same as the ones I let you use on the day of the test. You can type the problem in exactly in the order you see it on paper. To get to the inverse sine function, okay, on most calculators, well, and on mine too, you got to press second and then sine. So you have to press the second button. Some calculators might call it the shift button. If you use a Casio, I've seen that. They call it shift. All right, but on mine, you got to press second, 0.65, close your parenthesis, and you hit enter. And that's the answer. Now, what did I say earlier about inverse trig? Every time you use inverse trig, you're solving for what?
The angle.
Always solving for the angle. That means you need to label it. Especially if it's in degrees, you have to put the circle. So the answer here is 40.54 degrees.
Do you want us to include the decimal time?
Yeah, we're going to at least 2 decimal places, yes. Now, if you want it in radians, you don't have to type in anything different. All you have to do is switch the mode. I think we talked about that last week. You can press mode and just change to radians. And you can type the same problem in again. Let's type it in again. And in radians, it's about 0.71. Do I put RAD after it? Nope. If it's radians, you don't have to put any label at all. All right. So let's say this was a multiple choice question. Just give you 3 choices. And let's say I gave you choices of 0.71, 40.54, and 0.65. Which one is correct? There was only one answer that's correct. Yep, Ellie?
Wouldn't it be the 40.54 because you asked for the angle of the sine?
In this case, it wouldn't be the 40.54.
Oh,
What? Remember, because I asked for an angle, right? So we know these are all angles, which means all these numbers are in what units? Even though I don't say it specifically, I did say it by the way I wrote the answers. Yeah?
It'd be 0.71 because 40.54 doesn't have the degree sign.
Right. This 40.54 has nothing to do at all with that. They're 2 totally different numbers. All right? So in this case, the way I wrote the answers, the correct answer is A. Now, what if I did this? What would be the correct answer now? Yep, right?
It would be 40.54 because of the degree sign.
Right. Now the correct answer is B. You'd never have 2 answers that are correct in the same multiple choice. There will only be one answer that's right. Questions on that? Okay, I've seen that mess up a lot of people. I have a whole section that just asks you for doing problems like this, and they do every problem in the wrong unit. They don't pay attention to whether it's radians or degrees. So just pay attention if it's radians or degrees. All right, let's try this one. Inverse cosine negative 0.24. All right, can someone tell me how I would type that in on this calculator, and then I'll show you how to do it on a different calculator. Yep.
The D is second, and then cosine, and then you would put negative 0.24.
And just to bring it up too, because my calculator has this, there's a difference between the negative sign and the minus sign. They're not interchangeable. Okay, the minus sign on this one is right below the 3. The negative sign is over on the right. And you can see they look different. So, inverse cosine, negative 0.24, hit enter. And that is the correct answer in radians. This question didn't really ask you use radians or degrees. So if it doesn't say, you can do whatever you want. On the homework, it might allow you to do whatever you want, but on the test, I will ask for one or the other. All right, and just, I'll do it in degrees real quick. So mode, change to degrees. 103.87. And if you want to check it, I mean, it'll take you about 5 seconds to plug it in and check it. Take the cosine of 103.87. You get roughly negative 0.24. That's exactly what you were supposed to get. All right, so when you type it in on a calculator like this, I like that because it's simple. You type it in the order you read it. Some calculators, you have to type it in backwards. Okay, so not on mine, but you might have one like this. So let's do the inverse cosine of negative 0.24. First thing I need to do is put in negative 0.24. So I have to type that part in first, and then I press this down arrow that says trigonometry, press second, and then press, what are we doing, inverse cosine?
Yeah.
And I get 103.89. So I had to type that in completely backwards from what I did the first time. If your calculator works like one of these, and you're comfortable with it, fine, use it. If you'd rather use one of mine, because you can type it in the order you see it, then you can use one of mine. Whatever one you use, just make sure you know how to type it in. All right, and let's try inverse tangent. Tyler, can you tell me how to type that one?
You put in tangent, and then you type in the 34.3.
Like that?
Yes.
Do you see anything different about what I typed in and the problem?
Oh, it's the you have to put the negative, the square root or whatever, -1.
Okay, how do I do that?
You have to do the tangent, then second.
Well, do the second first.
Oh, you do the second.
So we're going to do the second first, and then the tangent, and now type it.
Yeah. Okay.
Okay. So if you're looking for an answer in degrees, it's 88.33. Right. Anybody have any questions on how you do that in radians? It's just changing the mode. All right, let's take a look at the last thing. Inverse secant, inverse cosecant, inverse cotangent. Just like regular secant, regular cosecant, and regular cotangent, do you see buttons for those three on here? No. You don't have a button for it. So, how do we type it in? So let's say that I wanted you to take the inverse secant of something. Okay, I'll give you a number there. Inverse secant. I don't know what that's going to come out to. Let's just say when you get the answer to that, it comes out to y. You're going to plug a number in, you're going to get a number out. You'll get an answer. So what I'm gonna do here is show you kind of a pattern, and then the hope is that once you see the pattern, you'll be able to do any of these three without going through what we're about to do ever again. Okay. What I'm gonna do is I really wanna get rid of that inverse secant. I don't want that. Well, I don't really know how to work with inverse secant very much, but I do know how to work with regular secant. That's what we did last week. So what I'm going to do is this. There's no multiplication happening there. I'm taking the secant of each side. And when I do that on the left, regular secant and inverse secant cancel each other out. That's the first thing we said right here. They undo each other. It's like taking a number and then doing +6 and then doing -6. Well, you can just cross out the +6 and -6. It cancels out. So what you have here is that. If you take the secant of each side, it's going to cancel out the inverse secant, and now you have x equals secant y. Now, secant. Anybody remember what other trig function that was connected to last week? Like when we made a table, it was always across from one in a certain row. Yep.
Sine.
The CSC was always across from sine.
Oh, cosine.
Cosine. Does anybody remember what you had to do with the cosine? You had to flip it. So let's take and flip both sides of this equation. Well, if you're not sure how to flip x, pretend like it's just x over 1. As long as you flip both sides, that's okay. But you got to do it on both sides. So the left-hand side turns into 1 over x. But this is the one I'm interested in. What trig function, we just said it, when you take the secant and you flip it, what does it turn into? It turns into cosine. Remember what this was equal to originally. Originally, it was equal to y. I'm trying to get a formula again that has y by itself. What was wrong with it the first time? It was equal to something I didn't have a button for on the calculator. I'm trying to get y by itself, but I want to have something on the other side I have a button for. Well, now I'm going to have that, because now I've gotten rid of the secant function. Okay? I turned it into cosine by flipping each side. Now, how do you think we could get rid of this and get the y by itself again? What function could I use on both sides that cancels out cosine? And it's a function we have a button for on the calculator. Yep.
Would you multiply both sides by cosine?
Not cosine, but what would cancel out cosine? Inverse cosine. So now, if you take the inverse cosine of what's on the right, take the inverse cosine, well, what's on the left, what's on the right, these cancel out, and you're back on the right-hand side to exactly what you started with. Y is by itself again. But the left-hand side isn't the same anymore. It's that. So if, let me just move this away so you can see it clearly. If you have to take the inverse secant of something to get an answer, instead of doing inverse secant, you can get exactly the same thing by taking and flipping what's in the parentheses and doing inverse cosine. That's the only way to do inverse secant, because you don't have a button for it. So you have to do two things. Take what's in the parentheses, flip it. Take your trig function and change it. And just so we remember which ones change to what, let's just write them down. So inverse cosine, actually I'll do it this way. Inverse secant is going to change into inverse cosine. How about inverse cosecant? Which one is that going to change into? Yeah,
Sine.
that's going to change into inverse sine. And why do we want to change it? Because we have a button for it. If we don't change it, we don't have a button for it. And how about this one? Inverse cotangent would change into, yeah,
Tangent.
inverse tangent. All right, so that's the first thing you do. Change your trig function, flip the number that's in the parentheses. Okay. So a little more complicated because we don't have a button, but that's as simple as you can make it. So let's try this one. Inverse secant of 1.45. First of all, I'm not going to be able to look that up in the table. Okay, it's not there. Second, we don't have a button for inverse secant. So, what trig function can we use instead of inverse secant that we have a button for? Yeah?
Sine. Well, the, inverse of sine.
If it was CSC, then yes, I would say inverse sine.
Cosine.
Yeah, inverse cosine.
Sorry, I wrote it opposite on my paper.
It's all right. So you change the trig function, and now you can't use 1.45. What are we going to change 1.45 to?
One over 1.5.
1 over 1.45. So it still involves flipping something. It's just not quite the way we flipped it last week. You're only flipping the number that's inside. And now we have this in a format you can type in on the calculator. All right, so inverse cosine, 1 divided by 1.45. It's 46 point, we'll say 46.40. All right, try another one of those. Inverse cosecant of 2.6. All right, first question. Is 2.6 a number that comes up in the table? No, so can't use the table. All right, fine, we have to use a calculator. Do we have a button that says inverse CSC? No, so we have to change it. What does inverse cosecant change into? So you can do it on the calculator. Yep.
Inverse sin.
So it's going to change into inverse sine. And if you change your trig function, you also have to change the 2.6. What does the 2.6 change to? Yeah?
1 over 2.6.
1 over 2.6. And now we have something we can type in. 1 over 2.6. And there you go, 22.62. Okay, I'm only doing it in degrees, but if you want radians, you just change the mode on your calculator. All right, last one. Inverse cotangent, 0.35. John, is 0.35 a number we can find in the chart?
No, I don't think so.
No, if you look back at it, you're not going to find 0.35 anywhere in that chart. Okay, so fine, we use a calculator. Do we have a button for inverse cotangent?
No.
Nope. So what can we change it to that we do have a button for?
Tangent. Inverse of.
Inverse tangent, yep. So you can change the trig function, but you also have to change the number. Jason, what are we going to change 0.35 to?
We are going to change them to
It's the same way we changed the last two.
Okay, gonna be over. No, I'm not sure.
Yep, Gene? 1 over 0.35. So the only time you have to change the trig function is if they ask you to do one you don't have a button for. Okay? If they ask you to do one you have a button for, don't do any of this. Just type it in. You don't have to flip anything or do that. You just type it right in. Okay, so 1 divided by 0.35, that's 70.71. Alright, and that's how you type in inverse trig on the calculator. Okay, questions on that? Alright. So, that's homework for tonight. The 22 to 31 and 33, those are all calculator questions. So if you don't have a calculator and you want to take those out, get those done real quick, I can get calculators out and you can do that. If you have anything else you need to talk to me about, we've got about 15 minutes. Would be a good time to come check in with me. Yes?
Can we see our test scores?
Yes, if you want to see your test score, we can do that too.